In a lab, you are often required to work with various solutions of different concentrations. The majority of the time, you'll be given a stock solution and expected to measure solutions out yourself. For situations such as this, there is a useful equation available. M1V1 equals M2V2. In this equation, M1 and V1 are the initial molarity and the initial concentration of the solution, respectively. M2 and V2 are the desired molarity and the desired volume of the diluted solution. Note that by volume, we mean the total volume of the solution, not the volume added. M1V1 and M2V2 are equal to each other because when you multiply molarity, moles over liters, by volume, liters, you are given the number of moles of the solute, which does not change when you dilute a solution. This is because the amount of solute stays the same and you are only adding more solvent, usually in the form of water. So, let's say you have a stock solution of 0.200 liters of a 15 molarity NaOH solution. The lab you are conducting requires an NaOH solution of 3 molarities. To what volume should the stock solution be diluted to? First, put in the values you know into the equation. In this case, M1 equals 15 moles, V1 equals 0.200 liters, and M2 equals 3 moles. You need to solve for V2. So the equation will look like this. 15 molarity times 0.2 liters equals 3 molarities times V2. Solve for V2 by dividing both sides by 3 molarities. Doing this, you are left with 1 liter equals V2. Now you can make the solution by diluting all of the 0.200 liter of the stock solution to a total volume of 1 liter by adding water to make a 3 molarity solution. When solving these problems, make sure you have the volume units in mind. The volume units should be consistent on each side to avoid wrong units in your final answer. For example, if you are diluting 175 milliliters of a 1.6 molarity solution of LiCl to 1 liter, the units for each side are inconsistent, so therefore require conversion. You can either convert 175 milliliters to 0.175 liters or convert 1 liter to 1,000 milliliters, depending on your preference. Either way works as long as both sides are the same. But in this case, we will convert 1 liter to 1,000 milliliters. After conversion, plug in the values that you know into the equation. That results in the equation of 1.6 moles over liters times 175 milliliters equals M2 times 1,000 milliliters. Then solve for M2 by dividing each side by 1,000 milliliters, which leaves you with 0.28 molarity. There are also instances when the moles need to be solved before setting up the equation. Let's look at this problem as an example. To what volume should you dilute 133 milliliters of a 7.90 molarity CuCl2 solution so that 51.5 milliliters of the diluted solution contains 4.49 grams of CuCl2? The first step here is to find the moles of the 4.49 grams of CuCl2. We can do this by using the mole ratio. The ratio should look like this. 4.49 grams CuCl2 times 1 mole CuCl2 over 134.45 grams equals 0.33395 moles CuCl2. Then, to find the molarity of the diluted solution, we divide the number of moles by the volume. This results in 0.033395 moles CuCl2 divided by 0.0515 liters, which equals 0.648 molarity. Finally, we can use the dilution equation and plug the values in. We plug it into the equation M1V1 equals M2V2. In this equation, 7.90 molarity is M1, 133 milliliters is V1, 0.648 molarity is M2, and we are solving for V2. After dividing both sides by 0.648 molarity, we find that V2 equals 1,620 milliliters. Now you know that you need to dilute the 133 milliliters of a 7.9 molarity CuCl solution to 1,620 milliliters. Thank you for watching.